Welcome viewers to the second segment of the fourth lecture for the online series of lectures for the course of Algebraic Topology 1. In the previous segment we have seen if we have a covering map from the covering space E to the base topological space B, and if we are given a path that starts at certain point B0 in the base topological space B, and if there is a point E0 in E such that P of E0 is equal to B0, right? So we have a path F which is a map from 0, 1 to B, and if this path starts at this point B0, meaning that if f of 0 is equal to B0, then we can find a unique lift of this path F in this covering space E, right? F bar that is going to start at this point E0. Okay. In other words, F bar of 0 is going to be E0. So this is what our lemma 1 stated, and we have proved this lemma towards the end of the previous segment. In this segment, we will have a similar statement for the case of the path homotopy. So instead of the path, we'll study the path homotopy now, and the lift of the path homotopy, which we claim to be unique as well. Okay, so let me state this second lemma concerning the lift of path homotopy, which is our lemma 2. Let P as before is a covering map from E to B, let P of E0 is equal to B0, let the map F from I cross I to B be continuous with F of 0, 0 being equal to that point B0 of B. Okay, there is a unique lift, or we call it lifting, of this continuous map F to a continuous map F tilde from I cross I to the covering space E, such that F tilde of 0, 0 is going to be equal to E sub 0. Okay, if F is a path homotopy, then F tilde is a path homotopy as well. Homotopic. So this is the statement of our lemma 2. let us prove this lemma. Okay. So let me erase this statement. I'm going to prove this now. Given f, so remember that we are given f, which is a continuous map from I cross I to the base topological space B with this boundary condition f at 0, 0 is going to be equal to B sub 0, and we also have P, the covering map, acting on some point E0 of the covering space to be equal to B0. Okay. All right. So given f, we first define f tilde at 0, 0 to be equal to E0, E sub 0. This is given. Okay, where P of E sub 0 is equal to B sub 0. Okay. So now we are supposed to construct this continuous map f tilde on I cross I, right? We are supposed to construct this continuous map from I cross I to the covering space E, okay? Right? So remember I cross I is, so this is 0, 0, and this is 1, 0, this point, and here is the point which is 0, 1, right? So it should be a little higher here, up here. Say this is 0, 1, so we have this square which is I cross I, and this edge is just, this edge is I cross 0, and this edge of the rectangle is 0 cross I. Okay. All right. So so if we have this, then this f tilde can be extended to these two edges of the rectangle, extended to the edges I cross 0, which is the horizontal edge, and 0 cross I, which is the vertical edge. Okay. So the bottom edge and the left hand edge, we can extend this f tilde continuously to these two edges. How? Recall that, so observe that f tilde restricted to these two edges can be interpreted as paths. Okay. F tilde restricted, well, no, I'm not talking about f tilde. So how can it be extended to the edges I cross 0 and 0 cross I? It's because let me write it, f restricted, so we know what f is, right? F is the continuous map from I cross I to the base topological space B, and if f is restricted to these two edges, I cross 0 and the bottom edge I cross 0 and the left hand edge 0 cross I, then f can be interpreted as paths in B beginning at f of 0, 0, which is B sub 0. Okay, so f restricted to, what I am saying is that f restricted to I cross 0 is a path in the first variable, and f restricted to 0 cross I is a path in the second variable, right? And both these paths start at f of 0, 0 is equal to B0. Then by lemma 1, these paths have unique extensions, right? Which we denote by f tilde, right? Unique extensions such that f tilde of, so f tilde is the unique extension such that f tilde as a path on I cross 0 and 0 cross I starts at the point E0. And since P of E0 is equal to B0, we are given this f tilde is the required extension on I cross 0 and 0 cross I. This is how we can extend f tilde from this, the origin to these two edges continuously. Okay, so this was the first thing to do. Now we do one thing. We now extend f tilde to all of I cross I. Okay, meaning that we need to define f tilde in all of this I cross I. This is what we need to do, and we'll do it using induction. Okay, good. All right, let me erase everything. I need space. Okay, so before starting this, note that using pretty much the same way we did for lemma 1, we are going to choose an open cover of the base topological space B okay, so these collection of open sets X, as X varies in the base topological space, is an open cover of this topological space B, where each of these open sets is evenly covered by the covering map P. this is guaranteed by the definition of covering map, right? So since this map F is a continuous map from I cross I to the base topological space B, each of these sets is open in I cross I, since F is continuous, right? So we take this collection as X varies in the base topological space B, we get an open cover of I cross I. So this guy is an open cover of I cross I. Okay, so by Lebesgue number lemma, there exists a positive number delta that we call Lebesgue number associated with this open cover. Okay, so we have this number delta, which we call Lebesgue number associated with this open cover of I cross I. Okay, so now we choose subdivisions S0, which is of course less than S1, and S1 is less than S2. Finally, everything is less than Sn. Similarly, T0 is less than T1, T1 is less than T2, all the way up to Tn. Okay, so we choose these subdivisions of I. Okay, this is a subdivision of I should rather say of the H I cross 0, and this is the subdivision of the H 0 cross I. Alright, so we choose these subdivisions of I. Essentially they are subdivisions of unit interval from 0 to 1, right? And we choose the subdivisions of I fine enough such that for each rectangle okay, so let me draw a picture here again. I'm going to draw the same rectangles over and again. So this is from 0 to 1, again this is from 0 to 1. Along the y-axis we have this I cross I, which is a square, and this is a partition of 0 to 1, which is of course I cross 0, right? And this is the partition of, right, 0 cross I, right? This is the partition of I cross 0, and this is the partition of 0 cross I. And then we have this elementary rectangles, right? These are the rectangles that we are concerned with, right? Okay, so we do this subdivisions fine enough such that for each rectangle, which we denote by I sub I cross J sub J. Okay, so I sub I is along this direction and J sub J is along this direction. Okay, so this is nothing but this subinterval from Si minus 1 to Si cross T J minus 1 to Tj, okay, where in this case I runs from 1 to m, right? And j runs from 1 to n. Okay, so each of these rectangles, for each of these rectangles, one has diameter of this rectangle I sub I cross j sub j to be less than delta, right? So okay, so we have this open cover of I cross I, and associated to this open cover we have this Lebesgue number, which is a positive number, delta, and given this positive number delta, we can find subdivision of, in fact we can find subdivisions of the unit interval, so that the diameter of each such rectangle for I between 1 and f and j between 1 and n to be strictly less than delta. We can always do that. And if we do that, then by Lebesgue number lemma, okay, then by Lebesgue number lemma, this rectangle whose diameter is strictly less than the Lebesgue number delta is contained in one of the elements of the open cover, right? This is the open cover of I cross I. So there is a member here in this collection such that this rectangle is going to be contained in one of the members here. So for some x in B for given I between 1 and m and j between 1 and n. Okay. In other words, we can rephrase this statement in the following way. We act f on both sides to see that f of this rectangle is going to be contained in u sub x for some x in B, okay, for given I between 1 and m and j between 1 and n, okay, where this ux is evenly covered by P, with ux being evenly covered by P. Okay, good. Now it's time to define f tilde. Okay. Now we define f tilde from I cross I to the covering space E inductively, beginning with the rectangle I1 cross J1, which is the first rectangle situated at the corner, at the left hand corner. So let me draw a picture for you. I don't need this part. Let me draw a subdivision. For simplification, I am drawing fewer rectangles. Okay, so I'm just using 4 rows. First row, second row, third row, and the fourth row, and we are using 7 columns, right? 1, 2, 3, 4, 5, 6. And there is one more, says 7. Okay, this is what we are calling I sub 1 cross J sub 1. Okay, this is what we start with, and we go along this direction along the first row. Okay, so we define f tilde in the first row here. Okay, then we move on to the second row and go along this direction, and then we move on to the third row, and then we move on to the fourth row. This way we define f tilde inductively. Okay. Now the idea is to fix some integer I0 between 1 and m, and another integer j sub 0 between 1 and n. Okay, fix these two integers first and denote by a the union of 0 cross I, which is the bottom edge, this one, and I cross 0, which is the left hand edge, here. Okay, so A is the union of these two edges, and all the rectangles previous to I sub I0 cross J sub J0. So let me locate, suppose this is our rectangle, okay, this rectangle, which we call I sub I0 cross J sub J0. Okay, so whenever we fix this rectangle for these two integers, positive integers, between 1 to m and 1 to n respectively, once we fix this rectangle, we choose all the rectangles prior to this rectangle, meaning that this rectangle, all the rectangles prior to these rectangles, because we are moving this way, so we choose all the rectangles prior to these rectangles, and that consists, so the collection of all the rectangles prior to this rectangle consists of all those rectangles I sub I cross I sub j for which j is strictly less than j sub 0. Okay, it means that all these rectangles in the figure it's the bottom two rows. Okay, these rectangles, all these rectangles. Okay, so this is what I have written in the notes. The bottom two rows in the diagram above and those for which j is equal to j sub 0. So we fix one row, okay, which is given by j is equal to j sub 0, and we want I to be strictly less than I0. Okay, so we are talking about these two rectangles on the same row of I sub I0 cross j sub j0. Okay, this, so so j sub 0 represents the row this rectangle is in. Okay, good. So whenever I am talking about this area A, it means that it is the collection of all the rectangles prior to this rectangle I sub I0 cross j sub j0, and the union of so the union of all such rectangles prior to this rectangle, and the union of the two edges, the bottom edge and the left hand edge. Okay, all right, good. Now let us fix the base case, because we are doing induction. What is the base case? Now the base case will be that the continuous lifting f tilde of f restricted to A can be constructed where A stands for this region, okay, except for this, these regions, this shaded region, okay. So only these regions. This rectangle is not included, okay. So this is A, and this is the inductive hypothesis that f tilde can be constructed, okay, if f restricted to A can be constructed, right? No, I think no. So the base case is that the continuous lifting f tilde of f restricted to A can be constructed. Okay, so the F tilde is the extension. F tilde is the lift of this guy. Okay, lift of this this map. So we assume that it can be done. This is the base case, and now we'll show that given this base case, we can construct F tilde in a sensible way on this rectangle as well. This is the first thing to show. We can do this. Let's see how we can do it. Okay. So this is what I need to write. We now define F tilde on I sub I0 cross I sub J0 in the following way. So we have seen earlier, okay, so before we mentioned about the inductive we mentioned about the induction. We have seen that F of I sub I cross J sub J is contained in some U sub X, right? For some X in B. Okay? For I between 1 and n, and J between 1 and n. This is what we have seen before. So now we choose since I sub 0 is between 1 and n, and J sub 0 is between 1 and n, we immediately see that I sub I0 cross J sub J0. So the image of this guy under F is going to be contained in some U sub X. Okay. So the image of this rectangle under F is going to be contained in some evenly covered open set U sub X. Okay. Now let V alpha, as alpha runs in the index set J, be a partition of the inverse image of U sub X under P into slices, such that P restricted to each of these open sets of the covering space E from V alpha to U sub X is a homeomorphism, right? Follows from the definition of the covering band. Homeomorphism for each alpha in the index set J. We know this. Alright. Now, according to the inductive hypothesis, which was this thing, right? Inductive hypothesis, F tilde is defined, since F tilde is defined on F tilde is defined here, right? In all of A. Okay. So F tilde is of course defined on the set C, which is the intersection of this area A with the rectangle I sub I0 cross J sub J0, okay? And this is nothing but the left-hand edge of this rectangle and the bottom edge of this rectangle, okay? These two edges. Okay, that's C. So since f tilde is defined on all of A, therefore f tilde is of course defined on C, right? Which is the union of the left and bottom edges of the rectangle I sub I0 cross J sub J0, right? It is evident that C is connected, right? These two edges of this rectangle, it is a connected space. And also we know that f tilde is a continuous map. F tilde is supposed to be a continuous map. So the image of C under f tilde is going to be connected as well, according to the theorem of points topology, like we have mentioned before. So f tilde of C is connected, since f tilde is supposed to be, let me erase this part. I need the figure, so I keep it. Since f tilde is supposed to be a lift of f, one must have P composed with f tilde is equal to f, right? Now, from the fact that we have mentioned earlier that f of I sub I0 cross J sub J0 is contained in U sub X, where U sub X is some evenly covered open set by P, right? Therefore, we just replace f with P composed with f tilde. So P composed with f tilde of I sub I0 cross J sub J0 is contained in U sub X. Okay, good. So that one immediately obtains f tilde of I sub I0 cross J sub J0 is contained in inverse image of U sub X under P. And from the definition of covering map, it can be written down as this joint union of splices, which are open sets in the covering space. Okay. So one therefore has f tilde of C, which is of course a subset of f tilde of I sub I0 cross J sub J0, right? Since C is just a subset of this guy, right? Therefore, f tilde of C should be a subset of f tilde of I sub I0 cross J sub J0, and this guy is a subset of this disjoint union as alpha varies in the index at J. This is our equation number 7. Okay, so we write this as equation number 6. Okay. Good. So this guy is connected, right? Since C is connected and f tilde is continuous, f tilde of C is connected, right? So since these V alphas are pairwise disjoint, this f tilde should be contained entirely in one of those V alphas. That's what we write here. F tilde of C is contained in V alpha for some alpha in J. Okay, let us denote this unique V alpha as V0. We call this V0. Okay, and the map P restricted to V0, we call this map P sub 0, okay, or P0. We use the shorthand notation P0 for this restriction. Okay, we know that P0 is a homeomorphism which maps V0 homeomorphically to UX, right? So P0 is a homeomorphism from V0 into U sub X. Okay, good. Now it's time to define f tilde. So it's time to define f tilde over the entire rectangle I sub I0 to J. I sub I0 cross J sub J0. Okay. Well, let me draw a picture. What does f tilde do here? F tilde is going to be the lift of this area is for this area I have this slice V0, okay, and I draw some, I only have a few rectangles, right? Only these are contained in V sub 0. This is one of those slices, and here is the map F, which is the, so here this is going to be projected to, so I should be careful about drawing it. It should be a copy of this guy, right? One of all the slices are going to be projected to this space, to this open set in the base space, right? This is U sub X, and these are the rectangles, right? Like this, and this is the covering map, right? Okay. Good. This is the diagram. Okay, now let me erase a part because I need room. I don't want to erase the diagram. Okay, I keep the diagram. Now, okay, so now it's time to define or extend f tilde from the union of these two edges, which is C, to all of the rectangle I sub I0 cross J sub J0 by the following definition. F tilde of x is going to be equal to, we have already defined what P0 is the restriction of the covering map P to the slice V sub 0, the unique slice that contains F tilde of C. Okay, so P sub 0 is, since this is a homeomorphism, we can take the inverse of this guy and compose it with F, and that map is going to be defined as F tilde for this rectangle. Okay, this is our equation number 9. So the extended map given by this equation 9 is continuous by pasting lemma. You can immediately check because all these rectangles that you have are closed in I cross I, and F tilde defined in this way will agree on the pairwise overlap of the rectangles. So by pasting lemma, you can extend the F tilde, the constructed map on each of these rectangles, to the whole of I cross I. Okay, so let me write it here. The extended map given by 9 is continuous by, not this map. So this map is continuous using the fact that it's a composition of the continuous maps. Okay, but this is just a continuous map on one rectangle. So you can join glued all these continuous maps to form this extended map F tilde on the whole of I cross I, and you can do it by guaranteed by the pasting lemma. Okay, continuous by pasting lemma. So you define, so this extended map F tilde is defined on all of I cross I. Okay, good. Okay, now it remains to show that F tilde defined this way is unique, right? And it actually follows from a beautiful generalized topological result. So that I am going to do in the next segment. Okay, so let me take a break here. I'll prove the uniqueness of this extended map F tilde, extended continuous map F tilde on the whole of I cross I, what we just did, and we are going to show that this is a unique map in the next segment. Thank you for attending this second segment.